just kind of taking some notes and doing some of these practice with us as well. So I'm actually going to share my screen and show you guys kind of a worksheet that I used to do with polyatomic ion, and that's kind of what. And I just kind of want to walk it through with you. Again, no assignment for today. It is just kind of talking a little bit about what are ions, and again, making sure we understand the difference between like what is regular ion and a polyatomic ion. So we should all know, and we talked about this last couple of days as well, that ions are charged particles that either need to lose electrons or gain electrons. When they lose electrons, they become positively charged. When they gain electrons, they become negatively charged. So if we look at this table above me here, these are what we call monatomic ion, just the atom itself after it lost or gained electrons. And these ions are stable because they have gained the electrons that they need. Remember, most atoms are not stable. In order to be a stable atom, you need to have 8 octet valence electrons, like noble gases, all the way over there. So helium, neon, argon, krypton. You need to behave like noble gases. And so you need to lose or gain electrons to be stable. And so nitrogen has 5 valence electrons. It needs 3 more to be stable. And so nitride is an ion that is stable. It has 3 electrons, 3 extra electrons. Sulfur has 6 valence electrons. It wants 2 more. And so it is going to be negatively 2 charged. And chlorine -1 charged. Well, the same thing with polyatomic ions. When you have multiple atoms that are bonded together, a lot of times they are not going to be stable until they get the number of valence electrons that they need. Okay, just like with the monatomic ion, polyatomic ions are also the same kind of category. And if you draw it, you'll actually notice that, yeah, you're right, Mr. Can. These need 2 more electrons in order to be stable. So, for example, nitrate, which is N with 3 oxygens on there, when you try to draw that, you will realize that you need 1 more electron in order to make this a stable compound. Okay, and so nitrate gets 1 more electron, it'd be -1 charge, but then nitrate can go and bond up with a positive particle because it's negative. Remember, opposites attract. Same thing for sulfate, which is S with 4 oxygen. When you try to draw it, you will notice that you need 2 more electrons in order to be satisfied. Ammonium, when you draw that, you actually realize you need to get rid of an electron in order for that to happen. Okay, and I can kind of show you that as well. Let's see here. Let me share the whiteboard again here. Okay, and so if I have nitrogen and 4 hydrogens, come on now. Oh, they're not plugged in? Sorry, 1 second. Little drawing thing not plugged in. So if I have nitrogen with 4 hydrogen, when I try to draw that, 1, 2, 3, 4, 5, and I connect these dots here, if I am going to connect these dots here, I got to get rid of that electron. I have to get rid of it, right? Because these electrons here, they're not going to bond up. They're already satisfied, they're already happy. Nitrogen already has all the electrons that it needs here, okay? So this is a stable nitrogen atom. It doesn't need to bond up with any more hydrogen, but you can if we lose this electron, okay, and that means that it becomes +1, then we can bond up with hydrogen over here. Okay, and so that is why ammonium is a +1 charge when you actually when you have that compound there. Then again, that electron is going to be gone. Okay, let's see here. Erase all of it. That electron is gone, and nitrogen now has 4 share 5, share 6, share 7, share 8, and it has the octet rule. But the only way for that to happen is if it loses an electron and becomes positively charged when that happens. All right, so go back to the other worksheet again here real quick. All right. So if we were to do this here, again, you can kind of figure out the charges of it. Nitride is going to be a -3 charge, which again, it's right up here. You know, a sulfate is going to be a -2 charge, but sulfide is -2 as well. Sulfite, which is this one here, again, note that they're different, okay? Ammonium, which is this guy here, +1 charge. Then you can actually write out the fact that they have multiple numbers. So again, monatomic and polyatomic. Monatomic just basically means one, mono, okay? Poly means more than one, okay, on that. So if you answer this question here, what types of elements, metals or nonmetals, are shown in the model number 1? These are all nonmetals because they want to gain electrons. Remember, that is the definition of a metal versus nonmetal. Okay, they don't have a brain. They don't say, well, I want to be a metal today. Like, no, they will either lose electrons, which are metals, or they will gain electrons, which are nonmetals. Okay, so nonmetals will always gain electrons. That is the definition of a nonmetal. They will have other properties because they gain electrons, and metals will have certain properties because they lose electrons, but that is literally the definition of those. Okay. What type of bond, ionic or covalent, hold atoms together in polyatomics? Again, in a polyatomic, all of these are nonmetals. Nonmetal, 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 nonmetal. These are all nonmetal bonds. And so remember, covalents are nonmetal bonds when they're actually sharing those electrons together. Okay. An ionic bond is going to be where somebody loses, somebody gains. And so after this has lost its electron here for ammonium, after it lost its electron, it becomes positive, then it can go bond up with a negative, and that is an ionic compound there. Okay, and ammonium nitrate, I don't know if you guys have ever heard that. That is a incredibly powerful explosive. It's in fertilizer, ammonium nitrate. If you buy a whole bunch of fertilizer from, you know, your hardware store or something like that with your credit card, it's going to trip the FBI and stuff like that. Like seriously, ammonium nitrate is a powerful explosive on there, so kind of cool. Yep. And it you know, chemistry does get fun when you actually kind of learn a little bit more about these the properties of these atoms and stuff. Okay. All right. The net charge of sulfide ion is -2. Explain how this ion attained its charge. Well, we already know that. So sulfide is sulfur. It has 6 valence electrons, and it gains 2 more electrons, which makes it -2 charged. Ammonium nitrate. I don't think ammonium nitrate is mustard gas. I think mustard gases had sulfur in it. Might be ammonium sulfate. I don't know which one mustard gas is. Be careful Googling things like that too. You don't want to Google how to make mustard gas or something like that. That would be bad. That would be bad. So that also tripped the FBI when you start Googling how to make certain things. So so don't do that. All right, number 6, the dotted line around each polyatomic ion in model 1 shows a group of atoms as a whole charge. The charge is not any one atom, but rather the group as a whole. Based on your knowledge of monatomic ions, propose an explanation. So I kind of already did this as well when I was drawing the ammonium here, okay? So again, when you try to draw these, you will realize that you can't connect all the dots, or stuff is going wrong here. You have too many, not enough. And so again, when you try to connect the dots for these polyatomic ions, that you're going to need to gain more electrons, or you're going to need to lose electrons in there. So that's basically why that as an entire whole is a -2 + 2 charge, okay, +1 -1, whatever it is. All of those together add up to be a different charge, not a particular atom itself. Okay. Let's see, what are similarity differences between nitrate and nitrite? So if you take a look at nitrate and nitrite, which are right here, you guys in the chat box, what are some similarities between nitrate and nitrite? Okay. So what are some similarities between nitrate and nitrite? Okay. And that makes sense, right? It starts with nit, the nitrogen. So yeah, we got nitrogen base in there. Right, the I have oxygen, good, right? And what else? What about the charge? Both of them. All right, so they both have a -1 charge. They both have the same charge on them. And that's important to note, is that how is it that they have a different number of oxygen, but yet have the same charge? Like you're telling me that they still need, they still need one electron, even though I keep adding oxygen to it, it still needs another electron in there. Well, draw it. Okay, let's do that drawing again real quick. Okay, let's go back to the explain everything here. I'm gonna use my new little trick for cleaning my board. Awesome. I really do like that. I know. All right, so if you try to draw a nitrate, which is NO3, okay. So nitrogen has 5 dots, right? So I need 3 oxygen. Let's go ahead and just connect that one up there. Because remember, the oxygen is bonded to the nitrogen there, okay? And then you noted that I could also bond up these oxygens here, but then there's nobody left for that oxygen right there, right? That oxygen's all sad. He doesn't have an electron anymore for that oxygen. There's no oxygen to bond up with that oxygen. And so that oxygen needs to gain 1 electron, and so this becomes a -1 charge, right? Well, I could do the same thing for nitride, which is NO2. So I can connect these here, I can connect these here, and then I can connect these here, and again, there's nobody left to bond up with this oxygen there. So what do I need to do? I need to gain 1 electron, and therefore this nitride is also a -1 charge. So you can kind of see we get creative with our drawings when we do this. And even though we add more stuff to, we added another oxygen, we still need the same number of electrons in order to connect all the dots, essentially. Then. Okay. All right, so does that kind of make sense why, even though you have a different number of atoms, you still have the same charge? Hopefully it does. No? All right. Cool. Good. All right, so let's go back to that worksheet real quick. Let's just see what else the worksheet wants us to talk about. All right. So similarity differences. So sulfate, sulfite, you're going to have the same issue there with sulfate and sulfite. Sulfate is SO4, sulfate is SO3, but again, when you draw it, sulfate is going to need 2 more electrons, and sulfite is also going to need 2 more electrons on there. And so that's the reason why, even though they are different formulas, they still have the same charge. All right, sorry, I'm flying here. All right, the chlorate polyatomic ion has a charge of -1. It is composed of 1 chlorine atom and 3 oxygen atoms. All right, so try that. Okay. Right, and so a chlorate there. So again, it's going to have a -1 charge when you do that one there. Try to, you can try to draw it on a piece of paper. Why is it a -1 charge? Anybody draw it? What happened? What happened with chlorate when you try to draw? When you try to draw ClO3. What happened when you draw that? What doesn't work? So what I have drawn here, what's going to end up happening? Anybody? Okay. I mean, yeah, that kind of makes sense. So chlorine, what we got, Sydney? Is everybody wearing green today? St. Patrick's Day. Yeah, so it's gonna be one without a pair. So if you take a look at chlorine, gonna bond up that oxygen. Chlorine done. We can't do anything else with chlorine. Chlorine got all of its electrons there. Okay. Oxygen can bond up the other oxygen there. That oxygen can bond up with that oxygen. And then you notice that we are still not happy there. And so what do we need to do? We need to gain 1 electron. And so this entire unit here is going to become a -1 charge because we need to gain another electron. Remember, electrons are negative. So if you gain another electron, you become -1 charged. Okay. All right. Now I'm gonna be really honest with you guys. This is not what the molecule really looks like. Okay, but I'm just showing you that it's still basic chemistry where we need the correct number of valence electrons. No matter how the compound is drawn or how it bonds up with each other, we still need to make sure that we have pairs that we are all bonding up. Okay, so again, it doesn't exactly look like this with chlorate, but for our sake, for high school chemistry, that's basically what's happening. Okay. All right, so let's go back to that worksheet real quick. I know I keep jumping around. I apologize. All right, so that's the chlorate. We drew it. Chemical formula for chlorate, ClO3 -1. Oh, chloride. Oh, that one didn't tell us what chloride is. So let's go back up here. You guys, So somebody talk about it in the chat box. What do you think chlorite is? If this is nitrate, this is nitrite, this is sulfate, and this is sulfite, what do you think chlorite is? So chlorate is ClO4 or 3. Chlorate is Cl. What is chlorite? What do you think? All right, so what do you think chlorite is? Yep, it's 1 minus. It's 1 less. It's 1 less the 8. The 8 and then the 8 is 1 less on there. So, yeah, good job. And again, what charge do you think chlorite is going to be? So nitrate, nitrite are the same charge. Sulfate and sulfite are the same charge. Then chlorate is 1 negative. What do you think chlorite charge is going to be? Yeah, it's going to be the same charge. It's going to be the same charge as the chlorate. And again, if you want to actually see that, you could draw it. Okay, you could draw the so the chlorate was CO3 1 minus. So the chlorite is going to be CO2. Okay, chlorine has 7 valence electrons. Oxygen has 6 valence electrons. Okay. Connect the dots. Chlorine done, can't do anything. Oxygen there. Again, I need to gain 1 more electron. Okay, so again, it kind of shows you how to pair these things up, right? Again, not exactly what the atom looks like or the molecule looks like, but for high school sake, that makes sense. So yes, chlorite and chlorate are going to have the same charge as the other one there. All right, I kind of want to end on that. Hopefully that makes a little bit more sense. Just know that there are lots of polyatomic ions, just like there are lots of compounds and elements and chemicals in the world. These are the really common ones. I gave you a PowerPoint slide of the ones that we're going to use in class. You do not need to memorize any, but I would just say that really, really common one is this guy right here, hydroxide. Hydroxide is, oh, sorry, you guys can't see that. I'm still on my little board thingy. Bouncing back and forth is kind of tricky sometimes. But on, I gave you a chart that look kind of like this on your notes. And one that's really, really common that we're going to use a lot is hydroxide. And we are going to use a lot in chemistry class. Hydroxide is a super common polyatomic ion. It bonds up with hydrogen to make water. And so there are a lot of these. It's a very, very common base, sodium hydroxide. That's a really common one, and is hydrogen with an oxygen. Okay, but there's only one hydrogen, one oxygen, and that's not enough. The oxygen needs another electron, so that's an OH 1 minus. This one right here is also a super common one called carbonate. You probably have heard carbonate before. Where have you heard carbonate before in your everyday language? Carbonate. So
Soft drink.
Yeah, carbonation, right? Carbonation and soft drinks that tend to be sodium carbonate. That tend to be what they put into there. So sodium carbonate, and that gives you that carbonate will turn into carbon dioxide when it is mixed in with the liquid, and that gives you a fizziness. When you drink soft drinks, well, not soft drinks. Soft drinks have a lot of stuff in them. But if you ever drink just carbonated water, just regular carbonated water called soda water, it is alkaline. It's basic. It's not acidic. It's actually a little bit basic, and some people can really taste the carbonation in it, the carbonate. Now, most soft drinks like Coke and Sprite and Mountain Dew, they have a lot of acid in them. They have a citric acid and phosphoric acid, and that's what gives you that soury flavor tasting, especially for Mountain Dew and citrusy drinks like that. They're gonna have a lot of other stuff in them, but that carbonate creates a very basic, not very basic, but it is a basic. It has a little bit higher pH on it, and it's just a little bit better mouthfeel, which is why we like to have carbonate in them. And you guys know what it's like. If you don't, if you lose your carbonation, it tastes different. It doesn't taste the same. Besides the bubbliness, it actually does not taste the same whether it's carbonated or not on there. Those two are going to be really common. Bicarbonate is also a common one, which is just carbonate with a hydrogen attached to it. Sulfate is common, but not super common in the everyday world, but it is common in the laboratory. Ammonium, you guys probably have some ammonium at home. If I get rid of the H, one of the H's, I make ammonia, not ammonium. Ammonia is what you probably have at home underneath your sink or in your bathroom. It's a good cleaner, ammonia. It has that ammonia smell to it. You know what it smells like. Especially when people get sick, like if they throw up or something like that. Ammonium is really good for cleaning that kind of stuff up. Also, in your pantry, in your kitchen, you probably have some of this, hypochlorite or chlorite as well. You probably have one of these two in there. That is a really common ingredient in bleach. Bleach is basically hypochlorite, and bleach is also good for reacting with things and killing things, bacteria and stuff. However, you do not want to mix ammonia with hypochlorite because they will react together because they're positive and negatives. They will join together, and they create a very, very dangerous gas. They basically create a chlorine gas, and it can kill people, especially at home. So you want to be very, very careful to never, ever, ever, ever mix ammonia with chlorine or with chlorite, hypochlorite. It creates a very, very nasty toxic gas, and it can kill people, pets, and things like that. There was a famous story not too long ago I don't remember where. I think it would maybe B-Dubs, Buffalo Wild Wings. I think with Buffalo Wild Wings a couple years ago, they mixed, or I think last year, one of the employees mixed ammonia and bleach together and ended up killing the manager when they realized what happened. I mean, you'll see it react, and you'll see gases falling on the ground, and end up killing the manager from it. So gotta be really, really careful, especially with cleaning products. They are nasty. That's how they clean. You know, they're nasty chemicals sometimes. Um, there are some things out there that are a little bit less nasty. They're called green clean or something like that, green chemicals. Uh, Unfortunately, they just don't work as well as the nasty stuff. But there's a pro and con when it comes to those type of things. Do you want to buy something that works really well but is really nasty, or you want to buy something that works okay and not as nasty? So if you have like children or pets and stuff, and you don't want them to get into things, you definitely look into other options as well. But anyways, that's a totally different tangent story, but important for you guys on it. If you do accidentally mix something like that, if you can, just take it outside, let it air out, but don't try to like stay in it. Get it out, get it away from you, get it away from animals and stuff. Try to get away from it as fast as possible. It's very, 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 very possible, and I've done it once before myself, to where you breathe in something and it knocks you out like immediately. That's how anesthesias or how anesthetics work. It's happened to me when I was in college. But some chemicals, they just overwhelm your body system and you can pass out. So if you pass out and you fall into the chemicals, then you can never wake up, basically. So you have to kind of be really careful with, especially with gases. If there's a gas or a vapor or an odor, you got to be really careful about, not falling into the thing that is causing you to pass out, and you stay passed out forever, basically. So you got to be really careful with that. Yeah, it happened to me with highly concentrated acid in college. I didn't hurt myself or anything, but it knocked me out for a second. Like, oh, that was strong. But yeah, gotta be really, really careful. All right, that's it for me today. You guys got about 10 minutes, hang out, chill. Remember, end of quarter is Friday. It's not impossible to get your grade up. I had one kid, you know who you are. I mean, I had one kid grade go up 30 points in one day, so just turn your work in, get your work done, okay? Again, if you have to pull an all-nighter, I hate saying that, but it might be something worth thinking about. I'd rather pull one or two all-nighters than have to worry about grades later on in the year. So, all right, if you guys need anything, let me know. We got about 10 minutes, get some work done, chill, and go eat a bowl of Lucky Charms or something. Happy St. Patrick's Day, everybody. So, hang out here, don't leave, but you guys are good to just to chill.